So this is, guys, this is the book assignment on page 104, okay? The actual assignment. But you're supposed to do problems 43, 44, and 45, which I haven't taught yet on regression. So I'm going to leave those till tomorrow. So that'll be your Thursday night homework. 3 questions. No, they won't take a ton of space. You might leave like a half sheet at the top if you want to put it all on one sheet of paper, or you can just put them at the end. It doesn't matter to me. All right, so the ones we're going to start with right now, start with 55. Okay. Number 55, the directions say find a polynomial function of degree n with only the following real zeros. More than one answer is possible. So it says the degree is n, which for number 55 is what? Okay. And then it says there is a 0. The only real 0 is also at 3, just to make it confusing. Both numbers are 3. How can we write this as a factor? X minus 3. Okay, and it's supposed to be degree 3. How are we going to make that a degree 3 equation? Okay, Samantha's suggestion is we just throw a cube on there. Does that work? Okay, so that would be a cubic slid to the right 3. The only real 0 would be at 3. Okay, why does it say other answers are possible? Extra what? Extraneous solutions? Not really. You could have imaginary solutions. Anybody know anything about that? So an imaginary solution, just a real easy one, I is an imaginary solution, right? What if I was one of your zeros? Does anybody remember anything about conjugates? If I is a solution, then negative I has to be a solution. If 2 plus I is a solution, then 2 minus I is a solution. So you'd also have to have this. Those foiled together become this. So here would be a degree 3 equation with only one real 0 at 3. The other 2 are imaginary. Okay. The other thing we could do if we wanted to be really tricky was like throw a stretch out here. There's another answer, right? You only have to have one answer. The plain old x minus 3 quantity cubed is fine. I just wanted to throw out some other information about why it says more than one solution possible. Okay, who's got me on 57? What degree are we talking about this time? Can you see the board, guys? It says the degree is n, so this one is 4. The zeros are where? Negative 5 and 4. So the factors are x plus 5 and x minus 4. Everybody good? All right. How are we going to write this so that it is degree 4? Okay, Samantha says put a squared on both. Will that work? They would both bounce, but would that have a solution at negative 5 and 4? Our book does not really differentiate between an x-intercept and a 0. I know if you've had college algebra, they make a big deal if it doesn't actually cross, it's not called an x-intercept. But our book says if it's even touching, it's an x-intercept. So this would work. Would that look okay and be degree 4? What else could we do? Do we have to square both of them? Could we put a 4 on one of them only? Why not? Yeah, if we put a 4 on one, it would be degree 5. But we could do an x plus 5 cubed and an x minus 1. That graph would be coming down through here and doing a little squiggly loop-de-loop and then going back up through here. Okay. That's supposed to be a 4, not a 1. I don't know how that became a 1. Just kidding. All right. What about 61? Who's got this one? (61) would be degree, it says n equals 5. The zeros they give us are at 0, 3, and -2. Ian, can you list the factors for me? Okay. Is that okay, what he said? Yeah. This is just a plain old x, right? And normally when we do it, we do subtract the 0, so x minus 0, but it doesn't matter. I'm just going to throw it as a plain old x out here. What else do we need to do? I don't know what happened right there, but x minus 3. Yeah, we needed to make it up to a degree 5. You want to square both parentheses? Is that a degree 5 then? Okay. Anybody want to offer me an alternative? Well, we could put a 3 on that guy out front, and that would work too, right? Degree 5? You don't have to have more than one answer. I'm just trying to make sure everybody's getting this. Everybody okay? All right, the next two you have to do are 66 and 67. And the directions say determine whether the degree n of the polynomial for each graph is even or odd. Okay, degree even, degree odd. Anybody know what that means? Okay, this is the highest exponent power is even or odd. How do you determine that? Just by looking at a graph. End behavior. Okay, so these are both going up, so this would be degree. Okay, yes, even. We're doing 66. What do you think on 66 though? Yes, this ends are going opposite directions, so this would be, the degree would be odd. Okay. And it asks, is the leading coefficient positive or negative? Well, odd normally goes like that, right? So this one is going this way, so it has a negative leading coefficient. What about number 64 that we started to talk about? That one was even with positive or negative? Positive. Okay, what about 60? What? One more thing. I just want to talk about what the degree could be, guys. This appears to have like some little loop-de-loop stuff there. Like there's a little min, little max, little min, max. Okay. If there are 4 turning points, this has to be at least what? Degree 5. Everybody good with that? You'd have to add 1. All right. So this guy over here, 67 has 3 turning points, so it's at least degree. Does it seem like it's an even degree or not? Both same direction. Good job. So this is degree even, probably 4, but it could be above 4. Okay. And both ends are down, so we're going to write leading coefficient is negative. Everybody okay on that? Do we need to practice writing end behavior? A surprising amount of people. Yeah, let me keep going on this because we're going to do 2 like that, so maybe you'll be better after we do these. All right, 83. Might need some people in the front row to help us with this, but we are supposed to list the least possible degree and end behavior, locate the zeros and their multiplicity, assume they are all integral values. What does that mean? Integers, which means, yeah, positive, negative whole numbers, right? They aren't decimals or fractions. Create Then we're supposed to create an equation that goes through the given point. We have this point on this one and this point over here on this one. All right. So for 83, what is the least possible degree? Why? Okay, 3 turning points means it's at least degree 4. End behavior, does that agree with us that the end behavior could be a 4? Or that the degree could be a 4? Okay. Locate the zeros. What do you think? The zeros appear to be at -4. Now, the graph paper is counting by 2s, so what do you want to call that one right there? -1. This one right here? 3. I only have 3 zeros. Is that possible? And their multiplicity. I need someone to explain which one has a multiplicity and why. Samantha, nice and loud. Okay. Does everybody see? Because it's doing a bounce there. We have to have an even multiplicity. They asked me earlier today. I don't get it. What do you keep saying? Okay, it's like a little mini parabola right there. Now, you could do multiplicity 4 there, but it will give you a different stretch at the end of the problem than we're going to get. Do you really want the stretch? I did it earlier. It's like we're going to get a 1/10 or 1/8 or 1/7 or something for the stretch. I don't remember. And if we did it with a degree 4 there, it's like 1/100th or something. Okay. You can do it that way, but it'll change your stretch. We just want to pick the smallest multiplicity that'll make it bounce. Does that make sense? All right, now who can write the factors for me? Got one for me, Katie? -1 would make the factor. And +3. And that one has multiplicity 2. I will tell you on the quiz, because it's the way it is on the final exam, this is not an A, it's a K. Does it matter? No, it's a stretch. Okay? Yes. How do you know that 3 has a multiplicity of 2? Anybody? Do you see how the graph hits there at 3 and then goes back in the other direction? It could be 2 or 4 or 6 or 8. It has to be even, so we're going to pick the smallest one that would make it bounce. Does that make sense? Okay. All right. Now what do we need to put in to find that value out there? X equals -3 and y equals -9. So we'll have -9 equals A times -3 plus 4 times -3 plus 1 times -3 minus 3 squared, which is -9 times A times 1 times -2. What happens back here? -3 minus 3. -6 squared should become +36. We good? So I get -9 equals -72A, which when you divide A will be 9/72 is 1/8. Everybody okay? I would take 0.125, which is equivalent. All right, so final answer, we just have to go back and slide that number in there, right? And we're done. Does it seem okay that it's a 1/8? It wasn't negative, right? We gotta be careful, because otherwise it would have opposite, that both ends would be going down. We're talking about this one. How could we check it if we were wanting to spend time checking it? Like on a quiz or test. Type this in your calculator, set the window up like this, and do trace -4, trace -1, trace 3, and trace -3 to see that it came out at -9, right? The other ones were the zeros. All right, 84. Who wants to try this one? Anybody want to try to explain it beginning to end? All right, how about start us out then? What were we supposed to do first? The degree? Okay, max, min, max, min. Warning, 4 turning points means degree at least 5. Does 5 work? Because it's odd, right? Both ends are going different directions. What was the second thing? Just list the zeros? And multiplicity. There we go. Zeros and multiplicity. Okay. Remember, it's counting by twos. I think this one is, what do you think? -3. Does that one have a multiplicity? Multiplicity 2. I know, it's really tiny. Somebody up here is going to have to help us. Oh, here's one. Crosses at -1. And over here, this one's right on 2, and it's a bounce, so it would be multiplicity 2. For the third time, you can use 4 or 6, okay? But it will change your stretch and make it more painful to find, in my opinion. So we're going to, just to be lazy, we're going to pick the lowest that would make it bounce. Does that make sense? Okay. If you want to make my life miserable and use a 4 or a 6 on a quiz, then I'm going to have to check if you got your stretch right. Okay? Just to make my life miserable. All right. Factors. Christian, can you give me a couple of the factors? If -3 is a 0, what's a factor? Okay. Y squared, Sarah. Okay, that one has multiplicity 2. All right, -1, Christian? Does that one need a multiplicity? Because at -1, it was just crossing up here, right? And last one, Christian? X minus 2, and that one? Yep, needs a multiplicity of 2. Okay, are we at the proper degree now? Yep. What do we need to do to find our stretch? Put in this ugly point here, 0, 3.6. I'm going to use K this time, but it doesn't matter. So we'd have 3.6 equals K times 0 plus 3 squared times 0 plus 1 times 0 minus 2 squared. 3.6 equals K times 9 times 1 times 4, which sometimes is 36 divided by 36, and we get, nope, we're trying to get K by itself, right? This is 36 over here. This one's the, you're okay? You're good. I'm just glad you're speaking, because sometimes you're really quiet, Lucas, and then I'm worried you're not with us. Everybody good that it's 1/10 or 0.1? I don't care which you use. Okay? So I'm going to cheat and just go back here and slide it in here. 1/10. For this graph, could I make the x plus 1 cubed? There would be a degree 7 then? Yes, if you want to be that complicated, you could. Absolutely. Yep. Every time you make it bigger, your stretch is going to get smaller. Yeah, you got it. So, and you're going to make my life miserable, right? And I'm just going to mark it wrong and say, prove it if it's right. Prove it. No, I gotcha. All right. That's the book assignment, guys. I have 3 minutes while they're singing the national anthem at the Cubs game. What do you want me to go over? Oh, worksheet 4B, number 2. Even after we did 2 of them? Can you try them? That's the ordered pair 0, 6. Yep. Okay, what Sierra's asking about is on worksheet 4B, when it gives you a picture like this, ooh, okay, and it says, instead of telling you like this is 0.012 or something, what it says is f of 0 equals 12. Everybody knows that those are the same thing, okay? That's putting to find it, okay? So if this was -8, you'd have x plus 8. If this was +2, you'd have x minus 2 squared because of the bounce. If that was 7, you'd have x minus 7. And then you'd have to put in a 12 and a 0 for all of these to find your k. Or seem okay now? Okay, try that. If you're having trouble still, let me know. Anybody else?